Hi everyone, welcome back to our course in college algebra. Dr. Tom McNamara here, continuing our work with graphing via transformations. Now the last three videos that we've posted have all dealt with transformations, but it was all translations, either moving the graph left and right or up and down. Now we know where to look for changes to the formula and see how they change the graph. If we change x, if we replace x with something, if we replace x with x minus 2, then we know that's going to move the graph 2 units to the right. You replace x with x minus 2, that's a shift to the right. If you replace x with x plus 2, that'd be a shift to the left. Okay? But what I want to do here is look at different types of changes that we can make, and we'll try to see what effect those have on the graph. So, given this graph, and this is just the graph of the function, we don't have the function's formula, we just have this picture, but remember that's all we need. I want to draw the graph of y equals 2 times f of x. Okay, so here's what I'm thinking. The change that I made here was to the outside to the function. So the change I made is to the outside. Notice the input to the function is just x. That's been left unaltered. I put a 2 outside. Outside the function affects the output, which is the y coordinate. So changes to the outside, we're going to change the y coordinate of the points on the graph. Okay, so let me get myself a grid here. I'm just using my finger to make sure the tick marks are equally spaced. Okay, so think about your anchor points. Plot where those end up, and then connect them to draw your graph. So I see this point is on my graph. That point is -4, 0. Now, when you change the outside, you do that exact change to the y coordinates. If you look back at our last video, we had a -3 on the outside. We made a change to the x value, and then we did -3. Notice we subtracted 3 from all the y coordinates in that video. Well, here we'll multiply them by 2. So multiply the y coordinates by 2. Only the y coordinates. Do not touch the x's. Nothing has happened to the input. So nothing is going to happen to the x coordinates. We're multiplying all our y coordinates by 2. This is -4, 0. 2 times 0 is still 0. -4, 0 stays where it is. This is -2, -2. Multiply the y coordinate by -2, we get -2, -4. Okay, that point ends up over here. 0, 0. Multiply the y coordinate by -2. You get 0, 0 back again. 2, 2 becomes 2, 1, 2, 3, 4. And lastly, 4, 0 stays 4, 0. So here's our shape. Here's our graph, okay? Notice you still have this zigzag going on here, but everything is twice as tall as it was before. And the stuff on the x-axis has stayed on the x-axis. Okay? Points on the x-axis have y coordinate 0. Once again, this point, 4, 0. What are we doing? We're changing the y coordinates only because there's no change to the x. And how are we changing it? Well, we're doing the change we see right here. Multiply by 2. Multiply the y coordinate by 2. You're starting out with 4, 0. 2 times 0 is still 0, so you get 4 comma 0. Whereas this was 2 comma 2. Hit the y coordinate only, with a multiplier of 2. So 2 times 2 of course is 4, so instead of 2 comma 2, 2 comma 4. Alright? So, we're looking at this expression and we're seeing what kind of changes were made. Was it a change to the inside? If so, that'll affect the x-coordinates. Was it a change to the outside? Like we're seeing right here. If so, that affects the y-coordinates. Let me do another example. Let's mess with something else. F of 2x. Okay, similar, but there's an important difference. Before the 2 is outside, now the 2 is inside. So here's our thinking. The change was inside. We change the x-coordinates. And only the x-coordinates. Changes to the inside affect the x-coordinates, not the y-coordinates. So we're not going to touch the y-coordinates. And remember, this is the same rule we followed with translations. You actually do the opposite to the x-coordinates of whatever the change was. Remember, if we replace x with x minus 2, that moves us to the right. We end up adding 2 to all those x-coordinates. So if x changes to x minus 2, you bump the x-coordinates up by 2. Here, we're going to do the opposite of this operation. Well, the operation is multiplication. What's the opposite of multiplication? Well, division. So we're going to look at our x-coordinates, and we're going to divide those x-coordinates by 2. So, once again, I'll get my grid going right here. Being careful to keep my tick marks evenly spaced. Alright, so, I'm looking at this point here. Negative 2 comma 0, those are the coordinates. I'm changing my x-coordinate. What am I doing? I'm doing the opposite of this. The opposite of multiplying by 2 is dividing by 2. I take my x-coordinate, divide it by 2. So instead of, oops, that's not negative 2, 0, it's negative 4, 0. What I get is negative 2, 0. Right? Divide that by 2. Okay, take this guy. Negative 2 comma negative 2. Negative 1 comma negative 2. Notice the y-coordinate remains unchanged. There is no change to the outside. The change is to the inside. So we change x. 0, 0 stays just where it is. This point right here, 2 comma 2 becomes 1 comma 2. 4 comma 0 becomes 2 comma 0. Okay, so we get this. Notice, same kind of zigzag, but now the graph is narrow. Originally, this was occupying negative 4 to 4 on the x-axis. Here we're going like negative 2 to 2. It's almost like this thing runs through the cycle like twice as fast. Okay? You're doubling how quick you go through the outputs. That's why it happens in that narrower span of the x-axis. Okay, let me try one more thing. How about this? We'll do y equals negative f of x. Y equals negative f of x. So So once again, we're thinking, where is the change? The change is outside the function. That is going to affect the y coordinates of the function. We're leaving the x coordinates alone. We're just messing with the y coordinates. All right, so just messing with the y coordinates. And what are we doing? We're doing this change. Hit them with a negative. Multiply by a -1 if you like. Same thing, right? Hitting them with a negative. Okay, originally got -4, 0. Change the sign of the y coordinate only, and it's still -4, 0. This is -2, -2. Change the sign of the y coordinate, and you get -2, +2. Right, there's the original -2, -2. Change the outside, you change the y, change that. Whatever you have for your y coordinate, do the opposite sign. So if you have a negative, it becomes positive. If you have a positive, it becomes negative. If you have 0, it stays 0. Okay, so we can see, once again, zigzag, but it's upside down. Vertical reflection. Okay, think back to what we already know. Okay, always relate the stuff that we're doing to stuff you already know. If I gave you this function and said graph it, well, you're looking at it, okay, quadratic function, so I start with the U shape. Negative means the U shape opens down. Okay, vertical reflection. You change the outside to a negative, you change the sign of all the y coordinates. So rather than the U shape opening up, it opens down. And then we would move 1 unit left and 3 units up, okay? Same kind of thing here. It's just with generic functions. Changes to the outside affect the y coordinates. Changes to the inside affect the x coordinates. Remember to keep those separate, okay? Don't mix them up. Outside affects the y coordinates exclusively. Changes to the outside leave the x coordinates untouched. Changes to the inside mess with the x coordinates exclusively. Changes to the inside leave the y coordinates untouched.